Okay, so let's move along now to the example down here. We want to estimate the slope of the tangent line at x equals 1 of this function d of x equals 3x squared minus 4x minus 1. We're not going to use the centered interval technique because we'll use the difference quotient. So what I'm going to do, again, for brevity, I'm going to pause the video and fill in a few lines to kind of zip things along a little bit. But what I would like you to do, now that we've seen a few examples, could you please use the difference quotient to find the estimate of the instantaneous rate of change of this function, which is also the slope of the tangent line, at x equals 1, and then check back to see how things are going, and then find the y-coordinate of the point of tangency, because it'll be when x equals 1. We'll find out the value of y at that point. And then on the next page, what we'll do is we'll find the equation of that line, that tangent line. Okay, so pause the video now, please, and we will, or please check back after you've done some of the work here. Okay, so what I'm going to do is, I know it's the average rate of change, so I'm going to say m is 3a plus h squared minus 4a plus h minus 1 minus 3a squared minus 4a minus 1 all over h. Now I'll fill in a few lines and then I'll come back here after I do some expanding and stuff. Okay, so what I've done is I've expanded this a plus h squared. Then I multiplied the 3 into that to get 3a squared plus 6ah plus 3h squared. I've expanded in the negative 4 into this bracket to get negative 4a minus 4h. That negative 1 stays here, and then I multiply the negative 1 into this bracket to get negative 3a squared plus 4a plus 1. So now I simplify things a little bit, so the negative 1 and this positive 1 go. Positive 4a and negative 4a, they go, and the negative 3a squared plus 3a squared, and they go. So what we're left with then is 6ah plus 3h squared minus 4h all over h. Okay, which is correct. We need all the terms with h's. Okay, if you can continue from that phase, that would be great. If not, pause for a second and I'll please come back and check with what you're working on. Okay, so I have factored out an h from each of these terms, so I can get rid of these h's, and then we're left with a more simplified form of the average rate of change formula, which is 6a plus 3h minus 4. And then when a equals 1, the average rate of change formula just becomes, after a bit of simplification, 2 plus 3h. Okay, so that's what we're going to use for the average rate of change. And then, of course, again, we do the preceding and following. And so then we let h equal negative 0.001. H is 0.001. And then we just find the values of m. So m is 1.997. The average rate of change is 2.003. And then the estimated instantaneous rate of change is the average of those two which when we average these two together and divide by 2, we get 2. So we have to hold on to that value for a minute. We want to find the y-coordinate of the point of tangency, so the y-coordinate is d of 1. So if we're finding the instantaneous rate of change of the tangent, or the slope of the tangent at x equals 1, the tangent is the point where the tangent line would touch this curve, and that point, or the y value, is negative 2. Therefore, the point of tangency, let's call it A, just for fun, is 1, negative 2. So now we're going to need this instantaneous rate of change, and we're going to need this point in order to find, on this side, the slope of the equation. Sorry, we're going to find the equation of the tangent line at x equals 1. So a couple ways we can do it. First of all, we can use y equals mx plus b form. We know the y value is negative 2. We know the slope is 2. X is 1. Solve for b. b equals 4. Therefore, y equals 2x. Sorry, negative 4. 2x and negative 4. The other way we can do it, we can say y minus y1 equals m x minus x1. So we say y minus negative 2 equals 2 times x minus 1. So the negative 2 is the y value of the point of tangency. The negative 1, or sorry, the positive 1 is the x value of the point of tangency. So we get y plus 4 equals 2x minus 2. And then when we subtract, we get y equals 2x minus 6, which, why are those different? Maybe because I did something wrong before. Well, if I meant to do that, here's a little challenge. Oh, there we go, right here. I was going to say, please find my mistake, and I found it myself right there. So that should be 2, and then that should be 4. Okay, so that is a wrap. Please start doing some of these questions at home, and then come in to class tomorrow to work on the rest of the questions. You have a test coming up soon, so begin working on the review. Please work on that as soon as possible, so then we can spend a lot of time taking up solutions to questions in the actual review period before the test. Okay, well, thank you very much for your attention, and we'll see you in class.